Another result of being able to see that a K is a result of its products on top and its reactants on bottom is that we can just look at a series of K values and we can tell whether or not you're dealing with like a kind of strong acid or like a really strong acid. You know that something is, when it looks like this, it means that this one is my reactant, which would be HA, and these are my two products. Sorry, I shouldn't have put them in brackets. I'm going to write that one more time. I was just seeing the brackets, I was getting excited. HA. And then one of the products is going to be the A minus, and then the other one is the H3O plus. So when we're saying products over reactants, that's where that's coming from. And if you can remember, if K is larger than 1, so that means that it's a big K. It means you have lots of products and you have very little reactant. Then you can say that it is mostly going this direction. And if most of it's going in this direction, then this one is going to be a pretty strong acid. So here's where you can look at some of the examples. So right in here, I have something that's to the -10th and the -4th and the -4th. These are all less than 1, but this one is a lot less than 1. So this is way, way less than 1. So this one is going to be my weakest in the group of 3. So HCN will be my weakest acid. When I look at the other two, since their exponents are the same, then I can look at the front number, and I can say that this is the middle of the middle acid strength, and then this is going to be the strongest. Note, all of these are considered weak acids, so I'm not saying that HF is strong. All are weak. But I'm saying within that scale of being weak, this is stronger than this one, and then both of them are stronger than that one. So here's a question first. Would a stronger acid have more H3O plus in the solution? The answer to that would be yes, because a strong acid, the better the acid, the more of this you end up with in the solution, because the HA breaks up into A minus and H plus. The H plus will react with water, and that's how you get the H3O plus. So a strong acid, like the strongest acids, completely fall apart in solution. You have tons of H pluses. The weakers don't do as much of it. Maybe 1 in 100,000 falls apart, but that's still enough for us to even register sourness, so that's kind of cool. Would that lead to a large or smaller numerator? So the numerator is the top. So if you have a lot of acid in there, then you're going to be looking at having, that's falling into solution as those little ions, then you're going to be looking at a really big numerator. Would a stronger acid have a larger or smaller Ka? Well, the stronger the acid, the more of this and this, so the bigger my numerator, and so the larger my Ka. And is this larger or this? This number is for sure larger than that number. And then we can review this again. Of these three numbers, this one is the largest. Sorry, I just said that weird. Of those three numbers, this one is the largest because of the 6.4 in it in the front, and then this one, and then finally this one.